Okay, so in our first types of problems that we're going to learn how to do today, it says when there's a fraction in the formula, first multiply both sides by the reciprocal. So R-E-C-I-P R-O-C-A-L. So reciprocal of the fraction. Because when in reality we can only multiply by 1 without changing the value of something. So if I take a number times its reciprocal, that's really 1. So I'm not really changing the value of the equation. I'm just multiplying it by something that would get 1, so it's safe to do. What's the reciprocal of 3? 1/3. 3 over 1, flip them, the reciprocal is 1/3. What's the reciprocal of 1/4? 4 over 1, also known as 4. What's the reciprocal of 2/3? 3 halves, 3 over 2, yeah. So, okay, so when we are looking at these, if we have a fraction in the problem, our first move is going to be to multiply both sides by the reciprocal of that fraction. So we have this fraction right here, 1/3. What's the reciprocal of 1/3? 3 over 1. So we're going to take both sides times 3. Well, the left side is not a fraction, so we don't need to really deal with 3 over 1. We can just do it as 3, because they're the same thing. But on the other side, we do have that fraction, so let's use our reciprocal as its fraction name. So notice, the only thing that I really did is introduce multiplying both sides by 3. As long as we do the same thing to both sides, it's okay. So 3 times b is
3b.
3b. 3b. What happens when you take 3 over 1 times 1 over 3?
It cancels out.
Cancels out and becomes 1. So, and remember, 1 times anything is anything. It doesn't change it. So if I just cancel these 3's out and cancel these 1's out, it's kind of like saying I'm actually now multiplying this by 1, so it's going to stay LWH. It doesn't have, we don't have to put that 1 in front of it. So we needed to eliminate that fraction. That's our first move. Okay, but now we need to go back up and look at what were we supposed to solve this equation for?
H.
We're supposed to get H alone. So what are we going to have to do next?
Divide
LW. We have to divide by LW because H is being multiplied by LW. So we're going to take, remember, write the equation again. And in this one is where we'll show our work of dividing by LW because that's what we want out of there. So our solution to this one, we can cancel out these L's and these W's. We now have the H by itself. And can we cancel anything on that other side?
No.
3b. So it's just going to have to stay 3b over LW. So again, really all we're doing is rearranging the equation we started with, and that's the formula. Does anybody happen to know what B equals 1/3 times LWH? What is that the formula for? What is the formula that we started with? B equals 1/3 LWH. What's that the formula? Well, what do you think capital B stands for, you guys?
Volume.
Volume. And then we have length and width and height. So it sounds to me like it's, yeah, 3-dimensional, correct? Volume is 3-dimensional.
It's the A for our
Pyramid.
It's of a pyramid, that's right. It is of a pyramid. It's of a rectangular pyramid is what this is actually the formula for. So we just rearranged the formula for finding the volume of a rectangular pyramid. Anybody have questions? So when you have a fraction in the formula, what's the first thing you're going to do? Multiply both sides by the reciprocal of that fraction. So let's do it one more time. I want everybody answering me. When you have a fraction in the formula, what's your first move going to be?
Multiply by the reciprocal.
Of the
Number.
Fraction, that was in there, yeah, multiplied by the reciprocal of that fraction. Okay. So now we look at some of, and we actually kind of had some of this type in there yesterday, but it was only a one-step one. But remember when we had multi-step equations to solve back in lesson 1.4, maybe it was, multi-step equations? If I wrote this equation up here right now, 16 equals 2x plus 4. Would you guys know how to solve that?
Yeah.
Okay, what would be your first move?
X is 6.
What would be your first move in showing me the work to solve
Subtract
it?
4.
Subtract 4 from both sides, get the 4 out of there first to get the 2x alone. And so now we'll have 12 equals 2x.
Divided by 2.
And then our next move would be to divide by 2 so that the x would be alone. And yes, I gave an easy enough equation that we could see the answer is 6. Okay, now there's a reason I'm doing this though. It isn't, you're not going to get answers like that in what we're going to do in this next one. You're going to, we have more than one variable. Look how many variables are in that equation. Y equals mx plus b. How many variables are in that? 4. There's a y, there's an m, there's an x, there's a b. We're not going to get a value like something like happened over here. We're going to have to rearrange it, and we're going to have to use the same process that we already know for solving multi-step equations. So sometimes you may have to undo addition or subtraction first, just like we did over there on that one that I was working on the board. Get the addition or subtraction undone first, because that's what we always did in these multi-step equations. And then we'll undo the multiplication. So take care of the addition or subtraction first, and then take care of the multiplication. Okay.
Isn't this what we've been learning like all year?
It is.
Well, why are we learning it again?
Okay, well, you go ahead and try and solve this one on your own then. Okay? See how you do. Yeah, because it's different stuff. It is. So thank goodness we learned that, because it's going to help us know how to solve this one. So what do we want alone?
The B.
No, it says the x. Yeah, we want the x alone. Well, so remember, this has four variables in it. We just follow that same process. So what's the first move we're going to make?
Divide M.
Subtract b. We want to get the mx alone first of all, so we're going to subtract b from both sides and make it look like a b, not a 6. Try to make it look like a good b, so you don't think it's a 6. Okay, well, can we really take b away from y? Can we combine them?
Yeah.
No.
It's A.
They're not like terms, so they're just going to become, it's just going to become y, subtract b. We just write it horizontally instead. Equals, this is gone, so we just have our mx left now. Okay? What would be our next move in this one over here? We divided by 2, so here we would divide by m. So now we're going to write the equation again. And Dakota, all 4 on you. And divide by m on both sides.
And you'd have x equals y minus b over m.
The m's over here are going to cancel away. Anything cancel on the left side?
No.
Nope, we can't cancel anything over there, so we say it's going to be y minus b. And you have to make a total fraction bar underneath that y minus b, because that whole side is getting divided by m. So now we have our formula, our equation rearranged and solved for x. Okay.
I did do it for myself.
So now do you see why that was important to know before we would do this? Okay. Do you see now why it's important to know how to do that before we know how to do this then?
Yeah, that's what we've been doing, right?
Mm-hmm.
Yeah.
So this was a stepping stone to be able to help us be able to do this.
But they're combined.
One's a prereq for the other. Okay, any other concerns about, we saw 2 different types here now. We saw the one where we have to get rid of a fraction first and then take the appropriate steps. And then our next one, we had a two-step one where we had to deal with getting rid of the addition or subtraction first, and then the multiplication. And again, we don't end up with pretty answers, so sometimes we're not sure if we did it right because of that. We don't get something like y equals 6, or... Okay, let's go to the back side. I'm going to guess this one should be hopefully a cakewalk.
Yeah.
I want you to take your pencil and show the rest of the work what you think you should do to solve this one for t. Because in reality, you already did something kind of like this in your homework for today.
Can I do it up there?
You can do it up there if it's done on your paper only.
Oh,
Yeah.
Why don't we just like use numbers?
Because,
It just seems kind of pointless.
right, because sometimes they want us to rearrange the formula so that when we, let's say we were going to do that one where we're finding the volume of the rectangular pyramid. Let's say they give us a whole bunch of volumes and lengths and widths, but they don't give us the height for any of those pyramids. Okay? So by rearranging the formula so that h is by itself, the height is by itself, then you can just plug in the numbers on the right side of the equation and simplify it really quickly. You don't have to follow such a process like this. It actually, one time you rearrange the formula and then it's more user-friendly for always finding the height. So that's kind of why we learned how to do it. Okay?
Can you tell me if I got these? I did the 4 2 to see if I can do it. Can you tell me if I got it right?
So, can somebody tell me what we need to do in this one?
Can I do it up there?
Well, did you do it on your own back there?
Yeah.
Oh, if you don't show your work, Trey, you gotta learn how to show me work and then I'll let you come up here and do it, okay? So Isaac, do you have work showing on yours?
Yeah, well, kind of.
I do.
I think I'm going to, we're gonna hold off. Malcolm, do you have work showing? Mrs.
Yeah.
Wilson, does you have work showing? Okay, come on up. Hopefully the next one right, okay, then maybe you can. So it actually works better to just write with your finger. Hold this in your hand and write, not with your pencil. And okay, thank you. How many of you agree with Malcolm that this is the, go ahead and take your pencil back to you, Malcolm. Okay, good job. This was just a one simple step to do it. We look at the, we say we needed to solve it for t, and Malcolm said, oh well, on the side where t is, r is being subtracted, so I have to undo subtraction by adding. So it was just a simple one-step one to do, wasn't it? M plus r equals t. Any questions? Okay, so I want you to at least decide what would be the first move you would make on this next one, and try and make just the first move on your own.
I'm done.
That's one.
This one.
So you want to go through your way? But just decide what's your first move. You want to get B alone. So these are the B's. Oh, you're still up here. Okay. Well, we want T alone. It says T minus R. How do we undo subtracting R? Add R. So you add R to both sides, not divide by R. Okay, so Payne, after you do the first move, can you just step aside for a moment and let's, because that's all I wanted them doing to start with. Okay, so do you agree with Payne that the first move in this one would be to subtract 2a? Yeah, because, okay, just a sec, because we need the 2b to be by itself, because eventually we want that to be a b, not a 2b. But first of all, we have to deal with getting those a's out of there. So that was a good first move. Subtract the 2a. Now we have b being multiplied by 2. So Payne, go ahead and show what you did next then. Go ahead if you think you know what you should do next. If b is being multiplied by 2, what do you think you have to do to undo that? And he's gonna show it one way, and then there's actually gonna be another way it can be done also, okay? So you just go ahead and try it on your own, see what happens. Because we got plenty of white space down there below. If you do it wrong, you can exit out and we'll redo it.
That's C or a B.
What?
That's C or a B.
Right?
A B.
It's a B.
There's no 6 in the problem.
Here, I got it.
And if I told them, make sure you can tell that it's always no, it was a little b, so we don't want to change it to a capital B. Formulas, it's important whether they're capital letters or small letters. So keep it a small b. Because sometimes in formulas, believe it or not, they will do this to you. They'll have a capital C in it, and then they'll have a little c in it. And you gotta be, they aren't the same thing. Okay? So, what did Payne do here? What does it look like he did? Divided every piece by 2. When you divide, you have to do it to every piece, or you can do it to the whole side. So this is one way, the way Payne has the answer. Okay, thank you, Payne. Good job. What's the one thing he could do, leave out of here to clean it up? What's one thing we could do to clean this up? Go ahead, Payne, what is it?
Could you take out those 3 2's and just draw one line and then a 2? So you divide it all by 2?
Yeah, that's one, well, on one side, but I'm asking on your answer right here. Do you know how this would be cleaned up? In other words, in the answer bank, there's something that would not be showing. No?
The 2A,
It would just be A instead of.
Yeah, it would just be A instead of 1A, okay? Now, that's one of the ways to show it. The other way to do it is, we were at the point where we had 2B equals C minus, or 2C minus 2A, right? I gotta go back and look and see what it was. Yep, C minus 2A. Okay, now, this needs to be, both sides need to be divided by 2. So we can just leave it so that the whole side gets divided by 2 like that. Over here, and this is important that you hear me on this right now because you're going to make this mistake if you don't listen. Over here, these 2's can cancel out because there's only one piece upstairs. There's just a 2B upstairs. They're connected. They're together. Over here, these 2's cannot cancel out because there are 2 pieces upstairs. There's a C and a 2A, and the only way it can cancel out is if it can cancel out of both pieces. Is there a 2 in front of the C?
No.
No, so we can't cancel this 2 because if there isn't a 2 here. If there was a 2C minus a 2A, then we could cancel all those 2's out. So it has to cancel out of both pieces. So in this case, we would just leave our answer like this. B equals C minus 2A all over 2. So here's one way to show the answer. I would not mark that wrong. And here's the other way to show the answer, Payne's way, where he divided each piece by 2. Okay? Anybody have questions or concerns? Okay, I'm going to put it so that you can see what Payne did back up here, so you can see that that's the other way to do it, where each piece was divided by 2, and C can't really be divided by 2, so that's why it got left C over 2. But here, these cancel out. That's how we got the 1A. And over here, these 2's cancel out. That's how we got the B by itself. Emerson.
In your problem, like down low, wouldn't 2 like cancel out 2A? So wouldn't it just be C minus A?
Okay, no it can't, because here's the deal, Emerson. Here's the only way that 2 could cancel out, is because there's 2 pieces up here. There's a subtraction, there's a piece here, there's a piece here. Because this piece has to have a 2 in it also to divide out, and it does not. So if there was a 2 here, then we would say, oh, there's a 2 in both of them, so now I can cancel it with the one downstairs. But there isn't, so we can't do that. Okay? Good question. Anybody else? So this was not how the problem was. That's just showing what we could have done if it had been that way. Okay, then let's get going.